Welcome everybody. So there were some topics that were left in the previous video regarding the summit curve. So that is what we are discussing today. So first is the position of VPI from VPC. So what is VPI? It is the vertical point of intersection, and what is VPC? It is vertical point of curvature. So what is the position of VPI with respect to vertical point of curvature? That is what we are trying to find out. This point will be known as A, this would be known as B, this would be VPT, this is virtual point of tangency, and the point B would be represented as virtual point of intersection. So we'll have a look at this triangle AVE we are having a look at. So in this, tan theta 1 would be equal to VE divided by X. That is what we have written here. Tan theta is equal to VE divided by X. So VE would be equal to N1X. This is one equation that we'll remember, right? Next, we'll have a look at the triangle BDV. In the triangle BDV, we'll have N2 is equal to, or we can say tan theta is equal to BD divided by VB. So VB, what we are having, the total length of the curve is given by LS. This distance is equal to X, and this would be LS minus X. So VD we are writing as it is. This distance we are writing as LS minus X, and this we are writing as tan theta 2. So that is what we have written. Tan theta 2 is equal to VD upon LS minus X. VD would be given as N2 multiplied by LS minus X. So now if we look at this, we can say that the RL of this point of B would be y dash B, from as y is increasing from this point to, as the x is increasing, y is also increasing. At x is equal to LS, y is equal to y dash B, we'll assume. So we'll calculate the value of y dash B. The value of A and B constant would be same. It would be minus n upon 2ls and n1 for B. So we'll put y is equal to, let me write that equation first. Y is equal to ax square plus bx, where b was equal to n1 and a was equal to minus n upon 2ls. That we'll have to remember. This equation we have to remember. So in the value of x we'll put ls, and in the value of x we'll put ls. So we'll get this equation. Y dash b can also be written as difference of VE minus BD. So this value minus this would give us y dash b. We'll input that value here, and after that, simplifying it, we'll get x is equal to ls by 2. This means that this is valid for a symmetrical and unsymmetrical curve as well. As x is equal to L by 2, the vertical point of intersection will be reached, or we can indirectly say that vertical point of intersection will be bisecting the whole curve into two sections of equal distance, right? Next, when the curve is symmetrical, there are some points that we need to discuss, that we need to remember. When curve is symmetrical, vertical line passing through the VPI will be bisecting the length of curve in two equal halves. This line will always pass through the summit point of the curve. Summit point is the maximum point that RL will be having. Next, in this case, RL of the starting point and end point is same. It is assumed that the RL of starting and end point is same. That is why it is symmetrical. If it is unsymmetrical, the RL of 2 points would be different. Next, when the curve is unsymmetrical, vertical line passing through the VPI will bisect the length of curve in two halves. It will not bisect the whole curve into two halves. It will bisect the length of curve, or we can say that LS would be bisected into two parts, right? Length of curve would be bisected into two parts. Next, this line will never pass through the summit point of the curve because the RL is not same. It will not pass through the summit point of the curve. Next, in this case, RL of starting and end point is different, and the curve is lifted. I'll give example of the lifted curve below. Next, we need to calculate the reduced level calculations for each point. So for calculating RL of point C just below the VPI, it would be given such that this point, what is the RL of this point? As we already know the RL of A, RL of some point has to be known, then only we can find the RL of another point. So RL of C is known, it is equal to RL of A plus Y dash, where Y dash, what is Y dash? Y dash is a point on the simple parabola where x is equal to ls by 2, as we have calculated here. At x is equal to L by 2, a summit point will be reached for symmetrical curve. So for that, C would be having, this value will be equal to Y dash, and Y dash B is representing different thing. This is Y dash, right? So CE would be Y dash. So for that, we'll put Y dash, x is equal to ls by 2 in Y dash, and we'll get this equation that will input and solve. So RL of C would be equal to RL plus RL of A plus N1 ls upon 2 minus N ls upon 8. This will have to remember. One other way to remember this would be to remember this. At what point of curve we want to find out the value of y, will calculate that accordingly, and we will not remember this because at some point of time it is possible that x value will change and it will not be ls by 2, that at that time this equation will be invalid. So for RL of point V end point, this would be equal to RL of A plus Y dash, where x is equal to ls. So RL of B is equal to RL of A plus Y dash, where y in this equation we'll put x is equal to ls. We'll get the value of Y dash. We'll get this equation. Next, what else we can do is we can find the n is giving us n1 plus l2 n2. So RL of B would be equal to RL of A plus ls by 2 n1 minus n2. In this equation we have put this and we have solved to get this equation. So we were discussing unsymmetrical curves. Unsymmetrical curves are such that if n1 and n2 is same, it would be a symmetrical curve with RL same point. n1 is greater than n2, then the curve would be such that it is lifted and B point is above the point A, and if n1 is less than n2, the point A would be higher than point B. So that is all, and next we will discuss the summit curve. For the time being, thank you for the video. Have a good day. I was supposed to write like, comment and subscribe. Kindly like, comment and subscribe to the video. Thank you. Have a good day. Take care.